Hello class, we are here today to show you what they call a virtual lab. As you all know, we are living under very difficult circumstances where we can't have hands-on laboratory lessons during this pandemic. So what we'd like to do is show you images, illustrations of what we would do if we were doing the hands-on lab itself. Okay class, so what we're going to do today is we're going to study a living creature that lives in the ocean, the oyster. And New York City was known at the beginning of the 20th century, 1900s, early 1900s, and in the late 1800s, as the oyster capital of the world. There were more oysters harvested from the local waters in this area than any other place in the United States. Sheepshead Bay, Jamaica Bay were epicenters for oysters. In fact, so many people bought oysters here that it resulted in these oysters are eaten raw, and after you open the oyster and eat what's inside, which is a soft-bodied animal, they throw away the shells. So we had mountains of shells all in this area as well as in New York City. What happened? New York City grew in population. The shorelines were extended. The habitat for the oysters, which is generally along the shore, was covered over by landfill. Pollution increased in the area, especially sewerage pollution. The result was by the early 1900s, we could no longer consume oysters from this area because the waters were too polluted. In fact, to this very day, if you buy an oyster in the store today, it's not coming from this area. It's coming from California, France, Japan, parts of New England, and out at the end of Long Island, but not New York City. So the Department of Environmental Conservation was looking at all these results, and they, along with the federal government, started to improve the quality of the water by putting up sewage treatment plants back in the 1950s, 60s, 70s, including one right here near Kingsborough Community College on Knapp Street, a big, huge sewage treatment plant. The result was that the water quality has improved. And so the Department of Environmental Conservation is interested in knowing how much has it improved the water quality. Can oysters still be harvested from these waters? So the DEC asked Kingsborough Community College if they would do some investigation, some research on the oysters. And of course you need a license, so we showed them that we have the equipment, we have the laboratory, we have the students that are interested. And so they gave us a license. So now what we are doing is we're trying to create an oyster garden. And we're going to put the oysters in the so-called oyster garden, which is a cage, which we'll show you in a few minutes. We're going to go out on the dock to show you where the oysters are. And to make a long story short, we're going to bring the oysters back, and we want to see if they're healthy or not. How do you judge healthy? So you might ask, why are these oysters important? Well, when you take a look at a dish of raw oysters, you can see that one of the major functions of the oyster is it provides food. It puts food on the table. These are raw oysters. After they're opened up, it exposes a soft-bodied animal inside. And nutritionally, the oyster is extremely valuable because it's very, very low in carbohydrates and fats. Very, very low. These are the two nutrients that contribute toward weight gain. When you eat food high in carbohydrates and fat, you gain weight. But the other nutrients are there in very large numbers, are very, very important. You need carbohydrates and fats, obviously. But you'd like to have food that have a very small amount of carbohydrates and fats, but also have the other nutrients. And they include minerals, vitamins, protein, and water. And that's what the oyster is high in. High in minerals, vitamins, protein, and water, which it's already in. So it makes it a very nutritious, healthy food to consume. Not only do oysters help us by providing a very nutritious food, they also are very useful in cleaning up the environment. Students a few years ago took a big large oyster, placed it in a jar of seawater which contained a lot of algae, called an algae bloom. And the reason is because oysters eat algae. They're microscopic plants, and they bring them in, and they feed on them, and they give off waste products into the water. This oyster was placed in this jar, and a couple of days later, the students came back and looked at it and saw what oysters do. So they are major filter feeders that clean up the water. So if there's a lot of pollutants in the water, they're going to go into the oyster. And that's one of the reasons we're studying the oyster. We want to find out how much pollutants can the oyster take. That's one of the studies that we do with the oyster. So they're very valuable. They clean up the water. They live together in these, they actually, when they're very young, they produce a cement, almost like an embryo produces a cement, then they cling together and grow together in these large masses called oyster reefs. And if you take a look at a small portion of a reef, you can see the other animals are attached, like this barnacle and this worm, tube worm, and a variety of soft tissue animals, including sponges, snails that will feed on the algae that grows on the oysters, fish that will feed on the algae. So what the oysters do in congregating together in a reef is produce a major important, what we call ecosystem. The ecosystem is an area of the environment which contains a lot of variety, a lot of biodiversity, that it allows for the increase in population of different animals and plants, and the oyster provides that. Very important. The oyster has enemies, and one of the enemies of the oyster, one of the predators that feeds on it, is this animal. Some people call it a sea star. Actually, you're more accurate if you say it's, it's a starfish, they say, but you would be more accurate if you said sea star, because it's not a true fish. It lives on the bottom. So the oysters live on the bottom. So if a sea star senses a mollusk like an oyster, it comes over, it climbs on top of the oyster, and using its legs, it completely surrounds the oyster on both sides, and the underside of the sea star contains millions of tiny tube feet, they're called, with a little suction disc at the end. As a matter of fact, the model for the tube foot resembles a plunger. And there are thousands of these tube feet underneath, and what they do is they attach to a substrate, a hard surface, and they push down and they pull back, and that pulling back causes pressure on the muscle. It causes on the oyster, that causes the muscles that are inside the oyster. That's muscle, not mussel. It's a different type of an animal. To weaken, and it opens up, and they release their membranous mouth into the oyster and feed on the inside of the oyster. That's a major predator of the oyster. Another predator is this tiny little animal called an oyster drill. Its mouth part is in the form of a drill, which you can see on one end there, you can see the narrow opening. There's the little mouth part that comes out. It's like a drill. It drills a hole in the oyster and creates an opening so that it can remove some of the soft animal tissue that's inside. Once that happens, it weakens the oyster. The oyster will probably, eventually, if it's attacked by too many of the oyster drills, it will open up, and as soon as it opens up, it dies, because all the other fish and crabs and the other animals that live in the area will come in and feed on the soft-bodied animal that's inside. So it has predators. So so I think we're ready to go outside and bring some oysters back and see how healthy they are, okay? When we're going out, we have to be prepared, because we're going to go out on the surface of the ocean on a floating dock. So we have to make sure that we are safe and secure. And one way of making sure that you're safe is you wear a life vest or a life jacket. We have the gloves on our pail because we're going to be taking material out of the water, which contains all kinds of marine animals on them. oysters, barnacles, and other creatures that can cause rashes on the skin, cuts on the skin, so you have to be careful. You should wear some good secure gloves. So we have the vest, we have the pail. We're going to bring back some oysters. Okay, so let's go. We're very fortunate at Kingsborough in that we have access to the ocean right next to the lab, just right across the parking lot. And as we walk over here, you are looking at, you can see actually Sheepshead Bay on one side of the campus. And it extends all the way around the corner of the campus into Jamaica Bay. So Jamaica Bay and Sheepshead Bay are continuous with one another. They're also called estuaries. And the reason for that is that along our shore, we really have a mixture of fresh water mixing with the ocean water. And the fresh water largely comes from the entry of the Hudson River, which is not very far from here, under the Verrazano Bridge. And it brings all that fresh water, which moves along the shore, mixes with the ocean water, which is very salty, relatively salty, and it creates a kind of salinity, what we call saltiness, that's called brackish water. And it's this brackish water that the oysters can live in. Oysters can't be grown in a river or a lake. Fresh water, they'll die. They need a certain amount of salt. And the estuary is one of the great locations for the harvesting, growing of oysters. So what we're going down now is we're looking at Sheepshead Bay, which is an estuary. And we're going down this ramp onto what we call a floating dock, which rises and falls as the tide comes in and out. And right now we're almost at high tide, and you can judge the height of the tide by looking at the bulkhead and seeing at different times of the day the water level is higher up or lower down. So the oyster garden is actually a cage, a metal cage, which has holes in it, which allows water to come and go. Here's an oyster drill right here. You just look at the oyster drill there. Okay. We have a few of them. We'll take a couple of them up. And once you notice that anything that grows in the ocean along the shore, it's in the water for any length of time, we'll get different types of marine animals attached to them. We call them encrusting organisms. Many of them are algae, forms of algae, small plants, different types of marine creatures. They'll attach to the pail. And so what we want to do is take, this is the one that we're going to bring back some oysters from. Let me open it up first. Okay, and we're going to take out what we do every month we come here to take them out. We're going to measure their height, the size of the oysters. And so you can see, if we take a few of them already, you can see all of these. All of these, we can look at them right now and say every one of these are alive. And the question is, how do you know by looking at them whether they're alive or not? How do you judge living oysters from maybe a dead one? So all of these are alive. We're going to place them in this container here. Got to be careful, we don't want to drop them. And we take usually 50 of them, and taking a look at them, and growing on them is all kinds of algae and all kinds of marine creatures that will attach to them. We may have some fish inside this container. Here you can see two oysters growing together. These are oyster shells. This looks like a shell. It's not. Yeah, this actually is a live oyster here, and this one is a broken one. No, it's actually a live oyster as well. Two of them, different shapes though. Now, here's one that's dead. Okay, so we have to record the live ones and the dead ones when we go back into the lab. So we're going to take these back. And we won't measure all 50 at that time, just a few of them, just to show you what variety there may be. But the students measure all 50. Here's another one here that's, what would you say that one was, alive or dead? The shells are closed tight, very tight. They actually open very, very slightly, less than a millimeter, to allow water to come in, but you wouldn't even know it. As soon as you take it up out of the water, they close shut. If they stay open permanently, it means they're dead. See, most of these are all alive. Every one of these are alive. This is in so-called polluted water. So we're doing okay. As a matter of fact, these oysters started, some of them are a different size. The oysters started in June. This was the size of the oysters that were put into the cage. This one obviously didn't grow very much. We still have to record its growth. And this is the size of since June. So you can see they're growing. How much are they growing? We have to determine that. Okay, so that's what we're going to be doing. So I'm going to leave those. We'll just take those back. We'll put some water in there. The oysters can be kept fresh as long as they're exposed to some water, cold water hopefully, or some ice, and they can stay for a good week or so, 7 days, outside the ocean. But after that, unless they get some food, then they're not going to survive. And if you put them in an aquarium tank, they won't survive, because the aquarium tank usually contains filters that filters out the plankton, the microscopic plants that they live on. So if you can get an aquarium tank that has plankton, they'll stay alive, but it's very hard because the filtering system takes the food away. So it's very hard to raise these oysters in filtered aquarium tanks. So we're going to put this back in. These are sea squirts. Can you see these ones? They squirt water out. They're invertebrates. Huge numbers of them. Let's see if I can get one to squeeze. They're shy. Here's some. Sometimes you see the water squeeze out. There they go. Do you see squeezing? See, squeeze. It's called sea squirts. Invertebrates. Animals without backbones. But advanced invertebrates, so to speak. Believe it or not. Okay, so we're going to take some water in here. Okay. Okay, we have our oysters here. And what we want to do is we want to check for what we call their viability, their healthiness. Viability is a way of looking at them in terms of how healthy they are, how viable, how much can they live. And as we mentioned earlier, one way is to check how much are they growing. Measure them every month. So every month the students go out, bring in 50 oysters, and we divide the oysters by groups. Generally, the full class is about 25 students, so there's usually 4 or 5 groups. Each group gets 7 or 8 oysters. And so all the students in the group can measure the oysters. They all have to have the experience of doing the lab as a group and work together to make sure the measurements are accurate. So let's do one example. We take the oyster, and we put them in the containers, in these food containers are a great thing. There's 7 in each one. Just put some water in there, you can. Some extra water, though you don't need to. You notice I'm wearing a lab apron, which is very advisable, or a lab coat. The aprons are very light and very useful to wear. And in addition, you'd be wearing gloves. Some students find wearing gloves are a little awkward in handling materials, and if they choose not to wear the gloves, that's fine, as long as at the end of the lab, good soap and water washing of their hands is required, so their hands are all clean before they leave the lab. Okay, so let's get started. We're going to measure the oysters, and one of the things that we still have a problem with, we're finding among college students, is that when we talk about measurements, they still use the English system in the middle schools and high schools and elementary schools. They don't use the metric system. And we're the only country left in the world that's still on the English system of measurements. And that has to really change. So we need to get the kids in to get science from the very early grades. using the metric system. And since we're dealing with length here, we're going to use the measurements of the meter as the standard size, and then the meter is made up of centimeters. There's 100 centimeters in 1 meter, and the centimeters can be subdivided again into smaller units called millimeters, mm. So this ruler has both English system and the millimeter system, and as soon as you give these out to the kids, they start using the English system. No good. We want to use the metric system, the millimeter side, so you can see starts with 0 all the way up to 30 on this. It doesn't matter how long it is, as long as you have enough of the size that you can measure an oyster with. So what we do is you simply take the oyster and place the oyster on the ruler, and the oysters really have a hinge at one end called the umbo, and we measured the length of the oyster, not the width. So you take the oyster and you place it right over that, and you look at the length here, and using a ruler, a pencil, just point to where it is, and apparently there's 1, 2, 3, 4, 5, 6, 7 and a half centimeters. But we want to measure in millimeters since it's still a small animal. So 7.5 centimeters, how many millimeters would be in 7.5 centimeters? And of course you can count them up. Ask everybody know when counts the lines. That would be 75 millimeters. So we're using millimeters in measuring the length of these oysters. So we would take that one particular oyster, and on our data table, if you look at the lab, every lab that we do here has a lab report to be done, and the lab report comes with results. The results are the results of your observations, which are measuring the length of the oyster. So we have a table of data, and for every oyster that's measured, it's placed into the table. Now we want to do 50. Each student does 7, so each one does 7, and we put them all together, and we wind up with a table of 50 for that particular lesson. So we can take this one here, and they would put then, what did we say, it was 75 millimeters? Okay, 75. Okay. You don't have to put, a lot of kids like to put millimeters in the square here. No good, because you have millimeters at the top, so you don't have to be redundant and put it at 75. So just put the number there, 75 millimeters. Take another one. Oh, look at this one. Right away, you have to find out, is it alive? I mean, you're only measuring live ones now. The dead ones you're not measuring. You're counting the dead ones. You can see the shell is open. It's dead. So we have to indicate dead ones, and the way we indicate dead ones is X mark. X marks the dead. Now, there's another instrument that we can use, which some students like to use, and experts also. Students can be experts as well. It's very accurate. It's called a caliper. And so you could take another oyster. Let's do another one here. Okay. And you just place this between the arms of the caliper. Just it in here nicely. And you can read off right quickly right here. Okay. If you look there and see, well, how big is that oyster? And if you could look at it here, it should be about 50. Okay, 50 what? 50 millimeters. 50. So this is a very simple, straightforward experiment, investigation to find out the size of the oysters. You want to take these oysters back and test them again the following month. And you want to look at if there's been any change in their size. And that's one of the ways of judging viability, is how much did they grow over a period of a year. And so our students have been measuring these every month, except the pandemic has prevented us from coming in here in the last couple of months. But hopefully the pandemic will peter out, and we'll be back in the lab very shortly, hopefully sooner than later, and we'll be able to do all of this. Right now we're giving you virtually, so you're somewhat familiar with what to do. We hope this is a beginning, a starter. This is not the lab itself. It's what you do. Your hands-on is really very, very important here. We can only show you the way, but you must do the experiment. You must work it out. Okay, let's take this one. This was a very early one when we first started, 2012. We got the oysters in July of 2012. Thank you all for participating in this research, because it's really very important to know that we can maybe improve the quality of food in the water by getting some research on the oyster, because pollution affects the economy. And when the oyster comes back and can be harvested, that increases the number of jobs that people will have selling the oysters, cleaning the oysters, catching the oysters. So pollution hurts the environment. And if we can show that there's been some improvement, I think it encourages us to be a little more optimistic about our future. Thank you very much.